The five senses are parts of our bodies that help us communicate with the outside world. The five senses are sight, hearing, taste, touch, and smell. What are some common misconceptions children have about the senses? The five senses are what connect us with the outside environment. Without them, we would have some major setbacks. Many children often think that these senses work in ways that they do not. Number 1, hearing. Children often think the only reason we can hear is because we are concentrating on the source of the sound. Also, they tend to think there is no similarity between light and sound. 2, taste and smell. With the sense of taste, children tend to think that taste is not connected to smell or the brain at all. Number 3, vision. The sense of vision many children think as a simple process. They do not recognize the necessity of light, nor do they realize the brain's involvement in perception. Older children tend to think that rays go from the object and enter the eye. Also, the children think that light travels out of the eye to light up an object.
So say you're looking at a flower in a pot. You might think, how do I see this object? I know that I see it with my eyes, but how do my eyes work? Well, we are here to explain it to you. Light is first focused on the cornea. The cornea works with the aqueous humor, which is a watery fluid, to form an outer lens that refracts light on its way into the eye. This process begins the eye's process of focusing on the flower. Once light is refracted, the iris takes over and controls the amount of light that is allowed to enter the eye through the pupil. The pupil gets bigger or smaller depending on how much light the eye needs to see the flower. Beyond the iris, the lens is used to focus further the image and send light rays through the vitreous humor and on to the retina, which is this purple line. The retina is very important for the eye. It is made up of millions of light receptors called rods and cones. The rods are more sensitive to light but cannot interpret color, and the cones allow us to see bright light and distinguish color in detail. Light enters the retina through the lens and stimulates the rods and cones. The retina then sends nerve signals to the optic nerve. The optic nerve carries signals to the brain. There, the brain interprets the two images of the flower from both our eyes into a single 3D image of the flower. Because the focusing action of the lens, the brain also takes the upside-down image of the flower and turns it right side up. Ta-da! The image of a flower.
Hearing is another sense that we have on our bodies. It serves two important purposes. The first, as you may guess, is to hear something, or for sound. The second is to maintain your balance. Some people are born without this sense of hearing or develop hearing loss later in life. Children actually can hear better and more of a variety of sounds than adults can. How does hearing work? Well, when an object makes noise, it sends out a vibration. These vibrations go into your ear canal throughout your outer ear. As the vibrations go through your middle ear, they hit your eardrum, which causes it to vibrate as well. This sets off a chain reaction of vibrations. Your eardrum vibrates the three smallest bones in your body. First the hammer, then the anvil, and finally the stirrup. The stirrup passes through the vibrations into a coiled tube in the inner ear called the cochlea. The cochlea contains hair-like cilia which move when the vibrations pass through them. The cilia change the vibrations into messages that are sent to the brain through the auditory nerve. The auditory nerve carries messages from 25,000 receptors in your ear to your brain. Your brain then makes sense of the messages and tells you what sounds you are hearing. In the inner ear, there is something called the semicircular canals. These help you keep balance. They are filled with liquid and hairs. Every time you move, the liquid moves too and sends a signal to your brain, and your brain tells your muscles which way to move in order to maintain your balance. The sense of touch is perhaps the most important sense for us. Touch develops first in the embryo and is the main way infants bond with the outside environment. This sense never is turned off and continues working every day, all day. The sense of touch is not centrally located because it occurs everywhere throughout the body. However, the most sensitive spots are the fingertips, tongue, and lips. The sensory organ for touch is the skin. It is the largest organ on the body and has numerous amounts of sensory neurons or nerve endings under every square inch of the skin. These sensory neurons perceive touch. This is what makes you feel anything: pain, heat, cold, etc. Each sensory neuron in the skin has a specialized capsule on its end, which links the nerve ending to the surrounding skin tissue. The nerve ending then changes shape when it touches something. After that, it detects this change in shape and produces an action potential, which sends a message out to the rest of the nervous system. The action potential codes for the touch's location on the skin, the amount of force, and its velocity. Other touch receptors in the skin produce action potentials in response to the object's temperature and to the presence of chemicals on the skin. The location in the brain where each sensory neuron goes off determines how touch is interpreted.
What happens when you bite into an apple? If only your tongue is working, all you do is taste it. Taste is the chemical sense perceived from the nerves that attach themselves to taste buds. If only the tongue is working, you do not perceive the flavor of the apple. You need your nose to do that. However, if you're only interested in the chemical process of taste, let's see what happens when the piece of apple is placed on your tongue. The tongue is covered in fungiform papillae. These are large bumps. On the side of each fungiform papillae are taste buds. Taste buds have chemoreceptors called gustatory receptor cells. Gustatory receptor cells have a protrusion called a gustatory hair. Their hairs reach the outside of the tongue through a taste pore. Molecules of the piece of apple mix with saliva, enter the taste pore, and interact with the gustatory cells. This stimulates the sensation of taste. Once this happens, called the gustatory impulse, the receptor cells pass electrical impulses to the brain, and the brain then interprets the sensation as taste. Also, traditionally, children were thought that there are regions of the tongue where specific tastes could be found. However, we now know that this is not completely true. You can actually taste in all areas of the tongue. There are only thresholds where certain tastes are the strongest. These thresholds are bitter, sweet, salty, sour, and umami, which is meaty and savory. What happens when you walk into a room where a delicious apple pie is baking in the oven? Well, vaporized odor molecules of the apple pie are chemicals, and they are floating in the air, and they will reach the nostril and dissolve in the mucus, which is on the roof of each nostril. Underneath the mucus, the olfactory epithelium, specialized receptor cells called olfactory receptor neurons, detect the odor of the apple pie. These neurons are capable of detecting thousands of different odors. The olfactory receptor neurons transmit the information back to the olfactory bulbs, which are located at the back of the nose. The olfactory bulbs has sensory receptors that are actually part of the brain, and which send messages directly to the most primitive brain centers, where they influence emotions and memories, limbic system structures, and higher centers where they modify conscious thought in the neocortex. These brain centers perceive odors and access memories to remind us about people, places, or events associated with these olfactory sensations.
What would happen if we lose one of our 5 senses? The loss of a sense or a couple senses may seem like a person is being deprived of communication from the outside environment. However, it is not the end of the world if we do lose a sense. Many people who have lost senses learn to cope with the loss. In fact, when someone loses a sense, his or her other senses become more sensitive because they are able to focus more on the other senses. Take Helen Keller, for example. Helen Keller was both deaf and blind, and no one ever thought she would be able to communicate with the outside world. In the end, Helen Keller learned to read, write, and speak, despite losing both her hearing and vision.